my name is Carly, and today I am talking on a slightly different topic from my colleagues who were presenting yesterday. I'm going to be talking about observability, and specifically the different tools that we can use for full front-to-back application observability. So the most of it we're going to focus on is OpenTelemetry and the state of client instrumentation and how we can correlate that alongside baggage, which we all have. But in this context, it's for correlating front-end and back-end signals. So we'll discuss that. We'll talk about RUM agents, and then we'll also talk about synthetic monitoring and how this all binds together. So I work at Elastic, as already been introduced. I lead the developer advocate team, and I also advocate for myself and get to come to conferences and do fun things like this. But the reason that I like talking about this topic is that I used to be a front-end engineer. I worked at Morgan Stanley for 10 years, building lots of very cool, big, large applications. And I was most notably a front-end engineer, which means I have felt the pain of having a lack of tools. I feel like I'm collecting social media like Pokemon these days, so just find me at the best place. So by all means, put your questions into the app and we'll discuss them at the end. But if you think of something afterwards, I'll be at the booth downstairs, or feel free to scan that QR code and come and find me wherever works for you. So it would be rude not to have a definition of what observability is, right? So taking the Wikipedia definition rather than the vendor-specific definition, we're talking about basically the ability to collect data about program execution, the internal state of what the application is doing, and how the components within an application are actually communicating together. So I mentioned I used to work on applications. There was distributed microservices all over the place. We had numerous front ends, and each individual front end actually was talking to multiple components as well. It was quite complicated. And I was the person that quite often in a problem situation was having to SSH into the box and then look through logs like this. Does this sound familiar to other people? Yeah, we're cringing at the thought as well. The problem is I've been in plenty of situations where this just doesn't work, particularly if you're trying to identify a cause of slowness. That could be anywhere. It could be specific to the front end. It could be one of these services. And I'm the person that's had to even correlate timestamps between different components to try and figure out what's going on, which is painful and horrible, and I don't advise it. But also some of the complexities, particularly as I did a lot of front-end web development, is there's factors around things like browsers, things about the location of users accessing things from, that can mean that there's other factors which are not picked up from logs. Most of us, believe it or not, are not putting in useful information such as the fact of the user is using Internet Explorer, despite the fact you've made it clear 10 times that support is not available for Internet Explorer, or they're using it in other places, and we want to know that information. Logs are not going to give us that, quite frankly. It's just not enough. So we need to think about it in terms of the other types of signals that we have. So we all know what logs are, right? Because we've just talked about these. Yes, we're nodding. It's these structured messages. If we think back to using Java as an example, we're used to sending those very easily using, an appropriate appender to send it directly to an elk stack or wherever it's going. But when we think about front-end applications, we just do console.log and then don't think about it. It's my experience that actually we don't tend to think about where these logs go, which is fine if you were me working with internal users, because you know what? I can walk downstairs 2 floors and actually go and sit in front of my user's computer, be shocked that they're using Internet Explorer still, and I can actually open the dev tools and see these error messages. But if you've got an external customer, which I imagine most of us do, you can't really do that, can you? No. So we need logs, of course, so we need to be able to capture those, but we also need metrics. So I guess a quick show of hands, who's capturing metrics within their applications at the moment? Okay, so a good chunk, that's cool. So we're used to this in the Java side. I think the backend services tend to be more evolved because using OpenTelemetry or even traditional monitoring agents, we can pull up useful things such as CPU, heap, thread counts, all these other kind of useful stats. So if things are starting to slow, we can get a rough indication of perhaps if there is something starting to go wrong, if things are trending the wrong way. And then we can start to maybe look at using profiling or other metrics to try and examine what's happening within that particular component, such as the time I saw a huge out of memory error in the logs, and it turned out it was trying to basically download this massive, huge XML file. But in front end, we tend to think about vitals and metrics that are more aligned to user experience, but these are still useful for identifying performance bottlenecks. So a quick show of hands for me. Who has heard of Core Web Vitals? We've got one person, which is good because by the time we all leave, we will all know what these are. So Core Web Vitals, set of measures, as you probably guessed by the big G, founded by Microsoft in May of 2020, have went through several different iterations and in fact are included under SEO as a category for rankings as of June 2021. But when we think about Core Web Vitals in the state of observability, they give us the ability to understand against, a benchmark best practice of how our application is performing. So historically, we would use tools like Google Lighthouse. Is anyone familiar with Lighthouse at all? A few more, cool. So tools like Lighthouse to basically run synthetic data against an application and say, hey, this is what my vital stats are looking like, and these are the potential bottlenecks and problems that I can remediate, looking for things such as, have I got images that are not correctly optimized and perhaps they're taking a long time to load, or other kind of useful stats and information. So for those who don't know about Core Web Vitals, we'll quickly walk through what each of these are so that you know for next time. So largest contentful paint is the first one. This is all about the notion of the initial loading experience. So have we all not had that experience where we're waiting for an application for ages and we're not sure if it's actually alive or not? Yeah, we've all had that in our personal lives. We've probably seen it in our professional lives too. So this is what this metric is about. It's ideally the render time of the largest image or text block visible within the viewport, i.e. the browser that you can see. And ideally, this measure should be under 2.5 seconds, because this is an important indication of, are you appropriately lazy loading artifacts that don't need to be there at the start, for example, in the loading? Are you making sure that you're giving appropriate responses to users? All these kinds of things that can stop them running off to a competitor page, for example. Now, we're going to talk about first inputs only, if only to give you a heads up that this is a deprecated measure. So if you do see this one popping up on whichever tools you're using, it might be worth looking at an upgrade because this was actually deprecated in March of 2024. It was replaced by a new measure called interaction to next paint. And the first is basically the key reason why that measure had to be deprecated and replaced with interaction to next paint. We're building complex user workflows in the web. We're having multiple stages. So capturing basically that amount of time to action one particular response to a user at the first action is not enough. It's not sufficient. We need to look at the whole cycle, everything they're doing, all the clicks, all the text entry, all that events, in order to get an idea as to whether there's particular sections in that flow that are perhaps slow, degrading, or unresponsive. So interaction to next paint superseded, obviously, March of last year, and it's the longest duration of the click, tap, and keyboard interactions throughout the lifespan of the page. Like any useful measure, of course, there are outliers. Feel free to go and check out. So web.dev has some fab articles on Core Web Vitals if you want to dive more into these later, because obviously I'm covering them from a higher level. And ideally, your IMP value needs to be under 200 milliseconds. Otherwise, we can end up with a situation such as key mashing, which we've all done. Just me? Am I the only impatient person on the web? Or other situations such as maybe they'll start to try and retry, which obviously might have an effect on your app, on state. It might even lead to the entire thing crashing. So it's actually a quite important metric to consider. Then the last one, which people don't necessarily think of, is why does this relate to performance? Because it's all about shifting of the layout. But if we all had that situation where the page moves on us and we incorrectly select the wrong option, is it just me again? No, it's not just me. Great. So cumulative layout shift is an indication of that error. It's also an indication of, if we think about, does anyone like to cook and use online recipes? Do we all hate the pages where you have tons of ads in between along with the life story of the chef and you just want to get to the bottom to the recipe? I feel your pain. It annoys me as well. These are the kind of things that cumulative layout shift gives us an indication. So you could argue it's probably more on the user experience side of things. But if your CLS value is higher, there's an indication of error. And that's something you want to try and eliminate, right? So it's basically calculated as the largest burst of all the layout shift scores throughout the entire application lifetime. And ideally, it should be under 0.1. Otherwise, you might end up with lots of errors. You might end up selecting the wrong item. And you'll end up with a rather buggy application that people just won't want to use. But it's not just that. There are other vitals too, okay? And we need to think about aspects such as page load, the loading time of assets, and quite often a common measure that people illustrate on this one would be time to first byte. Has anyone heard of time to first byte? More nodes here, cool. So this is basically the time between a request for a resource and the first byte of the response starting to come through. It's pretty straightforward. And ideally, the benchmark is 800 milliseconds. So it's not just the case that we track these measures using Lighthouse or some of the tools we're going to cover now. It's also the fact that we now have basically a benchmark of how we expect to perform against other web apps. And then traces. Do we all collect traces? Do we know what traces are? Okay, cool. That's good. Normally I get blank faces. That's nice. So traces, for those who are not familiar, it's basically showing the pathway of execution through an application. And why this is important thinking about the front end is, as I kind of said earlier, with a lot of my experience as an engineer before, I've had the situation where I have to figure out which service it is. It's not always just the front end. The problem I have is sometimes users seem to think that just because the number or that particular element appears on the screen, that it's a UI problem because they've picked up the term user interface when they've been chatting with you. And that becomes a problem because it means that whenever there was an escalation, quite often for the apps I looked after, I was the first port of call because it's like, this number's wrong, the UI is wrong. And I'm like, well, no, because that number comes from this service and all I do is format it. So that's not necessarily the case. So being able to see how long, which is what we get for spans, that time span for each element to see what's going on, not just on the front end, but all of the calls underneath, is therefore vitally important, especially if you've got multiple calls to different microservices as we go along. So I'll apologize if anyone hit the beer a bit too much last night. The first thing I'm going to talk about is rum. I'm not talking about the favourite beverage pirates here. I'm talking about real user monitoring agents. So a quick show of hands. Does anyone heard of a rum agent before? Okay, half of us. That's cool. So for those who are not familiar, a rum agent is basically a dependency that we include within our application that allows us to capture the errors and warnings from the console log because it will pick them up. It will pick up core web vitals and other useful metrics for observability. And it will also pick up tracing, which can, depending on the tool, also be correlated with the backend signals. The way that it works generally is that there are numerous rum agents out there. Quite often you have the case where every observability platform has their own. I'm going to use the Elastic one. If you're looking for a kind of open source alternative, a quite common pattern leverages Boomerang.js, which makes use of Grafana Faro under the covers. But you kind of get the idea. I'm going to talk about the Elastic one to show the capabilities of what these agents give us and why that's important for front-end observability. Because ultimately it's going to help us pick up the program execution and the communication among components. Internal state, you will get the console and error logs, but depending on the rum agent, it might not pick up those info messages either, so it can be limited depending on what you're doing. So we need a demo application, and I've got this one here. So anyone collect records at all? No? Okay. So this is my simple record store application where I can browse for records. I am able to search for them, to find records by the Beatles. I can subscribe to events with a simple alert. It doesn't do anything too exciting, super simple app, which we'll use to show RUM capabilities and also OpenTelemetry capabilities later. So the way to initialize one of these agents, you can do normally one of two things. It needs to be within the entry point of the application to initialize. Quite often you might see it included as a script tag on the top of the HTML file. I find that quite confusing, particularly if you end up with front-end frameworks. You know, if quite often you want that to be just the vanilla boilerplate. So I've got a simple Svelte app, which means I've put it in the initial page.svelte, so the entry point to the application. But sometimes you might want to use the HTML file, if not for it, if you've got a really aging app that you want to do the minimum and don't want to touch it. That means you can add in basic telemetry quite quickly. So once it's obviously imported using the npm package manager, I can initialize it. I need to give my component a name. Remember I talked about the fact of I want to see where the issue is. That means I need to have a unique identifier for my UI, not just each of the Java services that it's talking to. It needs to be sent somewhere. So it's going to, obviously, an Elastic cluster in this instance. And then I've also got the option, oh, interesting. There we go. I've clearly been changing things right before. I've got service and version and environment here. Now, I always add these in as best practice because I've been the person that's stung trying to figure out, did that issue in prod exist in UAT? Have we seen this before? Has anyone had that? No, just me again? Hey, not just me. Great. Thinking about what particular type of attributes relating to the front end is also important in that regard to allow us to correlate between the different environments, particularly if you're kind of looking at telemetry from like a non-prod and a prod perspective. But I've also got this notion of distributed tracing origins, because remember I wanted to talk about the fact of we need to correlate these things together. And the way that distributed tracing origins works is it adds the W3C trace parent header onto the HTTP request, allowing for it to be correlated with the backend signals via an APM agent or OpenTelemetry, which obviously we'll talk about later. So what does that give us? What does that give us that can actually help us understand performance bottlenecks? So here's the simple dashboard where you'll see it's picking up metrics, it's picking up the page load stats. It's also picking up the user agent information. So I can see who's using Internet Explorer without walking down 2 floors to their desk. Score. But I can also see the page load duration by region. So does anyone work on global apps that have users all over the world? Have you ever had to deal with issues where one particular area of the world is running far slower because of bandwidth or device choice, things like that? With the state of the web, that's quite a common problem, and you need to be able to diagnose those issues. In fact, I was recently at another conference, and one of the keynote speakers, Holly Cummins, was talking about the notion that for a LinkedIn feature, they figured out that it wouldn't work in India because people just, quite frankly, couldn't load it. You want to try and catch these things earlier, but also given the evolving nature of applications, we need to catch it whenever it happens, not just when we build the initial feature. Of course, we want to see the errors. We want to see if something bad is happening. And we also want to see when something bad is happening, is there an obvious pattern to it? Because then I can look at other things such as perhaps the information, the source element, and say, right, there's clearly a pattern here. It's not just a one-off what is going on. Right, so obviously we want an open standard, right? We want to deal with data that comes from open sources because that gives us choice. And that's where OpenTelemetry comes in. So a quick show of hands, who's familiar with OpenTelemetry? Not many of us. Cool, no worries. So for those who are not, OpenTelemetry is a CNCF incubation stage project. It's a collection of SDKs, tools, and technologies that we can use in a vendor-agnostic way to capture telemetry information from our applications. That includes backend services written in any language-compatible SDK, from Java to Go to beyond. And also it's talking about JavaScript front-end web apps as well. So I'm going to walk you through a very simple example, again with the same front-end application we've just seen. We have a proxy, and we'll explain why we need the proxy element in a minute. All the information is also passing through a collector, so collectors are quite useful if you have multiple services, and you might, or if, for example, if you've also got a backend being used by multiple teams, which can be quite common in enterprise scenarios. You might want to, make sure that you're dropping maybe duplicate events. You might want to make sure that they're routed to particular locations or other considerations of processing. And a collector allows you to do that in a way outside of the instrumentation for the application. Everyone with me so far? Great. So OpenTelemetry will give us each of the, going back to our definition, components that we want, the internal state and the execution. So what we're going to talk about is a Java example of automatic instrumentation, but the main focus is front end. We want to talk about client instrumentation and see what we can do in the open space outside of RUM agents, which tend to be vendor specific. And what you can see from the JavaScript SDK documentation is a few things of note. Firstly, it does have support for Node.js in the browser. You need to make sure, of course, you're using the correct implementation, but that is all indeed there. Second thing we should note is that traces and metrics are actually considered stable, which is great. Logs is very much in development, so that means it might be prone to change. So that might be something that you need to evaluate. I know certainly if I'd mentioned to some bosses I've worked with before, oh, this is under development, using it in production might be a bit of a, let's have a discussion about this, which is fine. But the other thing I want to call you out is the big red error message that is at the bottom there. Client instrumentation for the browser is experimental and mostly unspecified. So what I'm showing you are experimental features. They might change, they might break, but they are currently under work by the client instrumentation seg who look after these components. So if you are interested and you're passionate about this topic, you're interested in things like page view, event instrumentation, or even the Core Web Vitals plugin that they're working on at the moment, I would suggest getting involved. That's what open source is all about. So I'm going to show you an example using OpenTelemetry, but I'm going to use the Web Vitals JS library instead and show you how to build your own custom instrumentation. So let's go back to our little demo toy app again. So we're going to use the same application again, right? We have obviously several components that we talked about in our architecture diagram. So I have a very simple Java instrumentation. Can we all see that okay? Is that big enough? Sweet, okay. Where I'm using automatic instrumentation. So I basically use the Java agent option in order to specify the OpenTelemetry jar that I'm going to use by attaching onto the process when it starts. For Java, you can specify, with automatic instrumentation, you can obviously specify the options either by environment variables, as I have here, specifying the same attributes we had before for our RUM agent, along with the endpoint. I do need to specify my appropriate key or token for authentication this time. And then also traces, metrics, and logs, specifying the OTLP, OpenTelemetry protocol. Everyone with me so far? Sweet. You can also use the application properties file. So if anyone would prefer that over environment variables, that's an option too. And the docs cover how to do that without a lot of issue. But the main thing that we're focused on is the front-end instrumentation. So the general pattern for most of these types of data is that we create a resource that represents that particular component in our ecosystem. We'll have an exporter, which explains the format in which we want to send the data out. We then have a provider, which connects these elements together. And then you might have other custom things. So if we take logging as our initial example, you'll see that I'm actually detecting the browser resources using the browser detector, because I want that user agent information. Remember, I want to see who's using Internet Explorer or Chrome or whichever browser of interest. I want to also be able to specify that it's my unique web name. So I'm utilizing a service name along with defined environments, and then I merge them together. So I can combine the attributes of my own choosing with the detector options. Then I've got my exporter, and as you'll see from my comment, I'm sending it through a proxy. The reason I'm sending it through a proxy is I don't want to get stung with CORS issues. Have we all had cross-origin request problems in the past? It's horrible. So what I've had to do is add the appropriate CORS origin headers. There is, if I remember, a way to do it in the collector as well, but I've opted for using a proxy here. And you can see that I'm adding in the appropriate allow origin and methods to make sure that everything is going to pass through to the backend of choice. Okay. Going back to the implementation again, you'll see that for the logger, I obviously set the provider and then get the logger there. And I can add in the appropriate body of messages. So if I then go to Discover, you'll see that my logging messages are now coming through. I can do the same thing for traces. Again, different exporter, same idea. We use the web trace provider, not obviously the provider for logs that we used before. And indeed, I can specify multiple processors. So I have a simple one here, which is using the OpenTelemetry protocol. But for debugging purposes, using the console span exporter is handy because it will basically output it to the console as the name suggests. And obviously, you have different processors as well. So I've opted for the batch span processor to batch these together rather than just sending everything off in at one. What's that, sorry, Alan? Okay, cool. Thanks for the heads up. We then register it, making use of the context manager. So for web applications, obviously, Zone.js might be a consideration for some, if not all. So specifying the zone context manager will make sure that that async capability is coming through. And then we talked about this notion of baggage before to correlate. So the propagator is how that baggage is passed through together. And I have two specified here. So the baggage propagator will capture the headers and make sure those are passing through. And I also have the trace context as well, which is that trace parent header that I talked about before when we discussed RUM agents, okay? So, yes, want to show you some baggage. Right. So actually, before we talk about baggage, because we've all got it, here I've got the instrumentations. So I've got my fetching auto instrumentations configured for HTTP requests and also for fetch requests as well. So here's an example of an HTTP request coming through. And what you can see is my GET request comes through showcasing for the web component. And it is correlated with those backend services backend Java service that I had coming through. So that's all working as expected. The propagator is connecting those things together, and that means that Elastic's picking it up. We've also got document load instrumentation, which, as you probably guessed, is about document load. Remember I talked about the notion of we might have assets that are taking a long time to load. Think about things like style sheets. Think about JavaScript with not minified properly. Is that going again? Cool. We're going to keep our fingers crossed. We're good. Okay. So the document load is coming in here. So you can see here, not just the document load, but it's the amount of time to fetch the resources underneath is all coming through with the appropriate spans. So if I pick one, it was this one, I think. So you'll see that it's actually picked up the loading of the svelte file, which is useful. But then we've also got other assets too, such as the CSS style sheet. Everyone with me? Cool. Now, the other thing that we need to know about is user instrumentation, which is experimental, but we can, at the moment, add in the appropriate event names that we want to pick up. So here I've got an example picking up click and input events. So let's see what these look like. So here is an example of a click event. So you'll see, I can see how long that event is taking to process. But I can also see, using the XPath attribute, what element it is that I'm picking up here. So this is a header element, which is quite interesting. And I can possibly find out what page it's on. So this is the header element on our records page. Okay? The input works in a similar way, but again, through the use of baggage, we can actually see the correlation. So whenever I was inputting the value to search for in that search bar, it's actually also correlated it with the GET request coming back to the Java service as well. And again, I should be able to see what the XPath element, and I can see which page it is as well through URL attributes. And these all adhere to the common schema for OpenTelemetry. So in addition to these SDKs, we have established semantic conventions for the schema defining each of these elements coming through. Right, okay. But the last thing you'll be wondering is, well, Carly, you talked about Core Web Vitals. Where's that coming from? So here I have an example where I have built my own custom instrumentation. And what you'll see here is that I have a utility on report where I create my own trace. And I add in the appropriate Web Vitals attributes, which you're probably thinking, well, where's the Web Vital coming from? So when I enable the instrumentation as per the interface for the base, what you'll see is that I have these callbacks for each of the vital metrics, where I'm triggering that report attribute, and indeed I'm reporting all the changes, not just the first one that appears. That will give me the access to the data, sending it into, just as a trace, into Elastic or whichever backend I choose, which means I can then build my own dashboards on the top. So I have an example here where I've got my rating values coming through, and I've also got the view over time, which is also split down by navigation type. So these types of navigation are also picked up, which means you can start to do interesting comparisons. Does that all make sense? Cool. Right. So let's move on and talk about synthetic monitoring. So a quick show of hands. Who has heard of synthetic monitoring? Cool. A few of us. How many of us use it for pinging services? Okay. No one. That's cool. So this would be the idea of pinging a service, perhaps a Java health actuator endpoint saying, hey, this is alive, which is quite useful, particularly if you're trying to figure out, at key points in the day, is the application going to be responsive and available to users? So commonly in the past, I've used these for ready for business checks at key points in the day. And then I can see everything. I can see what's green and what's red. But actually, synthetic monitoring has evolved to include the user perspective. So many tools now have embedded automation frameworks, such as Playwright or Selenium. So a quick show of hands, who's heard of Playwright? A few of us. And what about Selenium? That might be a bit more popular. Yeah. So These tools can be used under the covers to basically automate that user perspective and the actions that a user is going to do, which means in addition to just saying, is a service alive, we can say, well, is this particular workflow operating? Is it perhaps running slower than expected? And start to look at the potential options there. And that will give us information about the program's execution. It's a bit more limited because it's just a snapshot of what's appearing, but it still, when combined with OpenTelemetry, can give us some useful insights. Generally, I've seen two ways of managing these. Obviously, you can, with some traditional tools, have them configured in the front end. The problem is you're then building these monitors against production, which might be fine, but if you then build a monitor that's going to do some actions it shouldn't do, then you might have some really awkward questions. You can make sure you use recorders, which is a low barrier to entry, but the disadvantage of using recorders is you have to automate. You basically have to, every time you change your workflow, re-record the entire flow, which is not fantastic. So we can make use of, similar to how we define infrastructure and other assets, we use monitoring as code. And the way that works is we basically have the monitor written as a definition stored under source control that you can run locally against a test version, or also manage and push to production whenever we're deploying the application to make sure that the monitors are kept in sync programmatically. So I'm going to walk through an example using Playwright, which is a JavaScript end-to-end testing framework maintained by Microsoft. It does have other flavors for Java and .NET, but we're using the JavaScript one specifically, and I'm combining it with Elastic Synthetics. And the way it works essentially is alongside configuration, we also have a TypeScript file, which is our monitor cum test. And that can be run locally, it can be run as part of a CI pipeline, and it can also be run against the production app as well. So once I've initialized it using my trusty helper, I end up with an application that looks, a structure that looks a bit like this. Is that big enough for everybody? Cool. So here, come on, there we go. So here you'll see in the test folders, I've got the journey. So these are the monitor definitions. And this is the configuration that drives how to run them. So looking at the configuration, given we're utilizing monitoring as code as a practice, you'll see that I specified by default the URL as localhost. And then using the node environment under which we're running, if it's production, towards the end of my file, I've changed it to run against my production version of the app. And for anyone that's curious, this is the production version of the app here. So it's a really simple order app where I can enter in my username and password, and then I can log in after both actions are there. I don't want to change the password because it was rubbish. And then I'm able to add items in. So a really simple like order app that you might be using. So if I go back to my replicator code, I can add in appropriate credentials like username and password. Obviously, don't use proper username and password that can destroy everything. Do think about the types of monitors you're running. You may want to consider about whether it makes use of test accounts, whether it makes use of other things such as, not changing production data, but you can pass in those credentials as well. And we can make use in Playwright of a notion of emulation, where we can specify not just the browser, but the browser and device combination to emulate those agents, perhaps captured via the OpenTelemetry data, to say, is this particular flow working for that user? We obviously have to figure out how long it's going to run. So this one's going to run in the production mode every 10 minutes, and it's going to run from this location specified here. The difference between this and an end-to-end test is actually quite small. So you'll see with Playwright, we have a traditional page object that we can pull out the elements using locators. I recommend data test ID because if you use ID in class, I've had the situation where all my monitors break when I make a small change to how the page appears, and you would like to protect against that, protect your time. And then with Playwright, we do things such as basically performing the clicks and text entry and events that a user would do. So I've got a simple example here for the login flow, where I'm filling in the username and password, as I just showed you, and then I'm clicking on the button after I've checked it's now enabled, and then asserting that the navigation works to the order page. The only bit that's different is that I split it using a journey instead of steps, because with a synthetic monitor of this complexity, you probably want to split it into smaller stages so you can see which particular element is starting to fail. Taking back that example where I talked about a cart, is it perhaps taking longer to process the payment? Is the payment service not available? If you just have one big test, you can't see that. So with this, I'm able to, here we go. run this locally. Okay, so that's all running through. I'm able to also run it against in production, in a CI pipeline as well. So here's an example, and I actually utilize a JUnit reporter so I can see the results. And then you push them to wherever you're running, and that will give you access to seeing not just the pings, but also that journey, what its state is. You can see how long it's taking to run. Also, how long each individual step's taking to run. If you think about that analogy I gave before, being able to see that it's the payment service that's taking longer. And then from there, we can start to see information on failures and also information on the metrics as well. So a lot of these tools will capture things such as the Core Web Vitals stats and the logs associated with that particular run, which if we combine with OpenTelemetry information can give us potentially the insight to try and catch an issue before a user does. And we can combine these sources together to say, okay, they've already spotted it. Let's try and figure out a plan to try and remediate it as quickly as possible. So we've talked about these 3 types of signal today. And we've talked about 3 different types of tools, not just OpenTelemetry, but others that can be used to capture these informations and give us an idea of what's happening within our application and identify bottlenecks and problems, not just thinking about backend services, but front end and how the whole picture fits together. If you want to dive into the code, that's the QR code there. And it has been a pleasure, Berlin. Thank you very much.
Okay, thank you, Carly. Does anyone have a question? I'm checking online. I don't see any question online. Yes, one question here.
If you've only got a limited bit of dev time to start playing with this, which part would you suggest people start with first?
OpenTelemetry. Because even if you're using obviously, for the front end stuff, you'll need to configure it because it doesn't have that auto instrumentation capability. But you can auto instrument your backend services normally quite quickly if that's supported, and then add in basic telemetry for the front end. And that also gives you an idea of what's happening to users, and that will help you identify bottlenecks. So if I had to pick one, that's the one I would go for, hands down.
Okay, thank you. Maybe another question? Maybe I have one question for you. At the end, you showed us how to write a scenario. Is there a tool to record a scenario automatically, and so you don't write the code from scratch?
There is, yes. So it does depend on what tool you're using, but there's recorders there's one for Elastic for the Playwright stuff, but there's also Playwright recording capability tools if you're just using that, and Selenium has equivalent recorders as well. So if you didn't want to, you can just basically, normally they spin up like a Chromium browser, you perform the actions that a user would do, and then it can generate the code as well. So that gives you either a boilerplate starting point, which you can adapt later, or it gives you the ability to kind of record a flow to quickly get a set to get started with.
Okay. Thank you.
Thank you.
Maybe one question? Yes.
Thank you. This may be a little off topic, but privacy concerns, when you're collecting all this data with real users, there's some privacy issues. Is it normally set up so that the one who's running the service actually collects the data, or is it sent to a third party where there's some issues?
That's a fantastic question, not off topic at all. So when it comes to collecting these types of information, you know how when you get the pop-up at the start that says you consent to giving your data over, quite often there might be not a marketing segment, but there might be a user analytics or telemetry segment. So what tends to happen is within a web application, you would basically have that option, and then in the event that a user doesn't consent, you wouldn't send that telemetry information. That tends to be the best practice of how to handle it. You are right, if you look at these tools, they can capture things such as user agent information. The RUM agent can actually give you some geodata, which could potentially be concerning. But that means you need to make sure that you're using it responsibly, and also that you're not collecting it if someone doesn't consent, and making sure that the consent is transparent so that people know what they're doing. and also make sure that you hold it as per GDPR for the right period of time and delete that information using appropriate lifecycle management. So you're right, there's considerations that you need to think of when you're using it. Does that make sense?
Okay. Thank you again, Carly. I think we can give a round of applause. Okay.